Eh, Voice clear. Ha, 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 ha. Hi guys. Welcome to Hacker Lab. So today we are going to learn about AI security modules and the learning path provided by the Tryhackme Labs. So my name is Ashwin Govin. So let's start the session. So here I have already logged in with the Tryhackme Lab. You have to go to the learn, or you can see in the roadmap there is one newly added enrolled path or latest path for the AI security. Let's look into it. First of all, there are pretty much things from the fundamentals till AI security level certification as well. All right. So what are the things contains in AI fundamentals? Fundamentals, they start with the AI/ML security threats. Oh, nice. AI model and data, prompt engineering, AI forensic, and I think containment is a solving lab. How can you help contain the ransomware threat with the help of AI? Oh, detecting ransomware using the AI. Let's look into it. Module two, which is secure AI system. Okay, how to secure the AI system, map AI architecture, identify vast atlas attack surface, and apply secure design to trust boundaries. LLM security, understanding the LLM, AI threat modeling, assess and mitigate enterprise AI ML risk via a systematic defender focusing auditing, auditing AI threat modeling. AI system reconnaissance, AI threat modeling assessment also there. Oh, nice. Then prompt security, prompt injection, jailbreaking, prompt defense, LLM Lamborghini, maybe Lamborghini instead of Lamborghini, then mention LLM Lamborghini. Maybe it's a lab solving lab. White Rabbit, AI supply chain security. Okay, they're mentioning like understanding AI security chains, supply chain attack vectors, securing the AI supply chain, payload, and two labs are there, payload and a checkpoint. We'll look into it. Data poisoning, rack security fundamentals, data poisoning in rack system, sensitive information disclosure, unindexed, maybe it's a lab, lockdown also lab. Then at the final, there will be one exam. How much it costs for attending the exam? Okay, it's cost around 22,600 and 10. Okay, let's start with the fundamentals. I'm going to open the first one, which is AI ML security threats. Let's understand. Let's start with the basic or the first one or the very fundamental things related to the AI. So here, what what they are mentioning in the introduction part. So the world is changing. Industries are coming to terms with the reality of how they will be affected. Artificial intelligence and the cybersecurity is no difference. It should come as no surprise that artificial intelligence is at the heart of many discussion in cybersecurity industry. A lot of ongoing research is being done to answer the question. So many have at this point of time, this room is aimed to answer these kind of questions. Okay, let's see the questions. What is AI machine learning, which is artificial intelligence of machine learning? How can it be used in the industry? How will be affect my role? How is being leveraged by attackers? There are a few questions we'll get or we can answer after finishing this lab. This room, this room or this intro room aims to ease you into the world of AI so that you can live with a better understanding of how the technology works and implication for the industry and the world as a whole. Oh, nice image. Hi. Learning prerequisite. This room doesn't require any previous room or modules to be completed, and in intended to be entry point in learning about AI. However, knowledge of cybersecurity basics such as common attacks is assumed. So you need to be well known about the cybersecurity attacks before going into the AI security. So what are the learning objective? Understanding AI, ML, and their impact on the cybersecurity industry, understanding a deep learning and neural network and how they have made application of AI we see today possible. Okay. Understand how adversaries use AI enhance existing attacks and take advantages of AI model vulnerabilities. Okay. Understand the key role AI will play in defending against AI. Let's look into these questions and we are able to answer these kind of things after finishing this. I am ready to learn about the AI security threats. Let's start building blocks of AI. We must empower our cybersecurity workforce to combat AI security threats. Knowledge is power. So we begin by arming you with the foundational knowledge of AI and ML. Let's start by discussing how we define artificial intelligence. Let's look into it. Artificial intelligence refers to the machine or computer system that is able to carry out the tasks that would be otherwise require human reasoning, comprehension, problem solving, or creativity. That's it. That is the major point which you need to understand while whether anyone asking about you what is artificial intelligence. It's a term that truthfully doesn't make or doesn't have just one simple definition due to that sheer scope of its application in today's society and its potential application in the future as well. All right. Still, we can use this definition to begin to understand what it is stand and where it is started. So let's use that one. This term and the field data or dates back in 1950 when research began on the pursuit of having machines perform tasks by simulating human intelligence. However, this will still a niche term that was not widely known. So there comes the term artificial intelligence since 1950. They are talking about the previous thing. How did the research begin related to this particular artificial intelligence topic? So let's look into what is machine learning. The significant advancement of the development of AI came with emergence of ML. ML is nothing. ML is subfield of AI that refers to a computer's ability to learn from data without being given instruction and is comparable to how the human brains learn. Over time, with more data and time, these algorithms will get better accuracy and decisions. So there is one data flow which is data and the algorithm works and it will look into the more accuracy to provide some good output. ML actually follows structured life cycle to ensure the reliable development and development of models. Okay. This process begins with defining the problem, such as determining whether an email is spam. Okay, they are providing one example. Next, data is collected, cleaned, and prepared to feature engineering, ensuring meaningful patterns are extracted by avoiding overfiltering. So when a model's familiarity with the training data cause failure to make generalization or unseen raw data. The model is then trained using a selected algorithm, followed by evolution and tuning to optimize performance. Once refined, the model is deployed into a production environment for real world use, such as classifying emails in real time. However, life cycle doesn't end there. Ongoing monitor ensures the model maintains accuracy over time, triggering retaining when needed. Hmm. That is a workflow of this ML they are mentioning. Since models require continuous improvement, the machine learning life cycle remains a iterative process. So that is the major thing. Still, this iterative process is ongoing to continuous improvement for this particular models. So let's look into this diagram. Model, okay. Model monitoring, define problem, where it started. Maybe it start from the model development. Model development, model monitoring, defining data collection, algorithm selection model, data cleaning, feature engineering, model evolution plus training, then again development. Maybe that is the structure or the uh, data flow. Machine learning algorithms. ML algorithms are the mathematical methods to learn patterns from data, while ML model are trained output derived from these algorithms. This algorithm consists of three key components: a decision process, which makes prediction or classification based on the input data, an error function, while evaluate performance provides feedback, and a model optimization process, which fine tunes the algorithm to minimize errors and improve accuracy. This iterative process continues until the model reaches satisfactory performance level. This is a thing, like it will iterate more and more to gain good satisfactory performance level. So ML algorithm falls into four main categories. Let's look into the four main categories: supervised, unsupervised, semi-supervised, and reinforcement learning. So supervised learning relies on the label data to train model classification or regression tasks such as predicting house price, identifying spam emails, or some these kind of like prediction house, identifying spam emails. Those were the supervised learning. Unsupervised learning, on the other hand, works with unable or unlabeled data to discover hidden patterns, often using clustering, association, or dimensionally reducing or reduction techniques. Then next one, semi-supervised learning. These are the combined elements of both supervised learning and unsupervised learning, using a small portion of the labeled data to guide the learning process. Finally, reinforcement learning mimics human learning by rewarding correct decision and penalizing mistakes, allowing an agent to refine its action over time to achieve best outcome. Okay, this is the reinforcement learning. So let's look into neural network and deep learning. What is it? Let's see. If you recall, the main objective of AI is to enable computer to behave like human. That is the main major thing or major goal of AI. One method that follow us to do through this through the use of neural network. Okay, the major thing which is the neural network. Neural network, which means our brains and things, kind of things. So that's the same concept they implementing here. So if you cast your mind back to high school biology, you may remember being taught how human brain works. The human brains process information using interconnected neurons, a type of cell responsible for transmitting communication between human body and the brain. Okay, the like go back to the high school biology topic. So you will be understanding how this brain is interacting or how the brain is processing the information. So which communicate each other using synapses. So synapse allows the brain to send electrical or chemical signals from neuron to neuron. In other words, they are a connection. So this network of neurons learns by adjusting the system of these connection when we experience something new based on the patterns we encounter. It's it's this behavior that is replicated in the neural network. So the same concept or same behavior they implemented here. The diagram below represent the neural network. So this one is a neural network in the AI. Like the human brain process sensory input, the input layer receive raw data with the number of nodes depending on the data type. Example, for a 4 into 4 pixel image has 16 nodes. So that image has 16 nodes, just image. Each node represent a neuron. So that nodes contain different neurons. So each pixel or each node represent as a neuron. And the connection between them as a synapse. Okay, that connection they mentioned as synapse. The hidden layer process and refine the input, bringing the network closer to a prediction. Each connection has a weight determining its importance. For example, in email classification, the body type might have more weight than subject line. The output layer then produce the final prediction. So that is the workflow, or that is the actual process or the neural network, how the neural network works. Consider the neural network tasked with the recognizing a number from an image. Each hidden layer extracts different feature. Early layer detect the edges and curves, while deeper layer combines these patterns to form a complete number. For example, lines may suggest 1 or 7, while curves increase the likelihood of 3, 8, or 0. So that is the prediction they are going to made to determine whether a number in the image. The output layer with 10 nodes, 1 per digit, select the mostly likely number on the highest prediction value. This self-learning process mimics the human brain. And when a neural network or when a network has more than 3 layers, it is classified as DL algorithm, which is deep learning. Hence the term deep learning comes. DL and ML can be get confused sometimes, but we can now understand the difference with what we have covered so far. Like ML, DL is concerned with receiving data as input and producing some kind of prediction or classification of output. That is a major point. DL can take labeled database like the one mentioned when covering supervised learning. But the key difference is that DL doesn't need the data to be labeled. A DL algorithm can be unlabeled, unstructured raw data and determines its key feature, which separate it from the other categories. The important advantage here over ML is that data doesn't need labeling. This means DL doesn't require human interaction, and in that way, self-learning, it makes sense that the DL is possible through a leveraging neural network. Because no human interaction or intervention is needed, large database can be processed and can then therefore be thought of as scalable ML. The idea of neural network has been around for decades and decades. I mean, decades and decades. So how come the true potential of DL has been exploded over the last date or last decades and so far? This is largely due to the mass digestification or digestion of information in recent years. Suddenly, masses of information was available to learning algorithm, and so with the DL started a new era of AI. We would unlock more potential capabilities. So these are the basic introduction about neural network, deep learning, machine learning, and uh, main major blocks of AI. Let's quickly answer these things. What category of machine learning combines both labeled and unlabeled data? So what is it? I think what category of machine learning combines both labeled and unlabeled data? Okay, labeled and unlabeled data, something they mentioned like uh, I think it's this one, semi-supervised labeled and unlabeled data, semi-supervised learning. Okay, okay. Okay, that's a correct answer. So, what is the first layer in the neural network that handles incoming raw data? First layer of neural network. It's in the image input layer, hidden layer, output layer. So, input layer will be the first layer of data. Okay, that one solved. So, which learning method does not require human label data and can extract feature from? It's deep learning. Okay. What are the weight connection between nodes in neural network mean to be simulate in the human brain? Hmm. That one we have read somewhere. It's that biological term which they mention of weighted connection. I think synapse only. That is the connection, right? All right, we answered. So we completed the task one. Let's look into the task. Task two. Let's look into the task three, which is LLM. Let's go through LLM, which is the task three part. What is happened? Oh, there are too many things about LLM. So let's look into it. Okay, so we have taken walk through history in this room. From our goal to have computers behave like humans, the AI field was born. A field that would come closer to achieving that goal with an introduction of ML. In more recent years, the further development of these field has allowed us to unlock even more potential with neural network and DL, both of which play a crucial role in enabling our industry or the next industry changing technology. That is what LLM telling us. Now, I am no ML algorithm, but what is this image? But if I had to assign a prediction score to change or chance of this room's users base having heard of ChatGPT, it would be very high. ChatGPT emerged smack back in middle of AI boom. Okay. Its ability to generate human-like text in response to a query or user query blew the minds of near everyone, with technology triggering discussions in the news, politics, education, industry. The list of okay, the list goes on. There are a lot of things. Something had changed. We were entering new era and everyone knew it, which brings up to date. Which brings up to date. Now let's look into how the technology were covered so far. Enabled LLMs like ChatGPT, Llama, DeepSeek to exit kicking of the technology or technological revolution. What are LLM? How does they work? Let's look into it. LLM, which is large language model, are the deep learning based AI models that can process and generate by the text the next word in the sequence. For example, consider this code. Ever have feeling where you have or you are not sure if you are awake or it's a question, right? This code is missing the final word. This code would be fed into LLM and it would be tasked with predicting what the final word is to be added. When you query a chatbot, this is what happened in the background. Predictions are being run quickly on what word would be likely be the next response of an AI chat in this query. But how? Let's look how it works. Excuse me. LLM are the first training in a pre-training phase. Okay, where they process vast amount of text. GPT-3 alone was trained on the data that would be like a human 2600 years to read non-stop. More advanced model like GPT-4 require even greater datasets made possible by DL. Instead of relying on label data, LLM use billions of parameters that function like puzzle pieces, enable them to understand, generate human-like language when accessed together. These parameters are fine-tuned automatically as the model process text, adjusting based on the prediction accuracy, improve response quality. They begin to generate a word random to finish the test. So let's ask again. Ever uh, let's ask this particular thing to the chat GPT or any chatbot. Ever have that feeling where you are not sure if you are awake or egg? The LLM will fill that blank portion with the term egg. So this guess is then compared with what the correct final word actually was, and the parameters are fine tuned to make it more likely to predict what in fact was the right word until the model can accurately predict the correct word in the end of that sentence and less likely choose the incorrect word using an algorithm called back propagation. So the LLM works. This is the diagram or the image. We are asking to the LLM. Ever had a feeling that where you are not so sure if you are awake or uh, it's a blank. So it will dreaming 65 percentage, asleep 15 percentage, hallucinating 8 percentage, alive 5 percentage, conscious 4 percentage, imaging 3 percentage. So it will uh, check what will be the most appropriate word that can add for this blank space. Now imagine the process of happening trillions of times, repeating this process over and over again until it cannot be only predict at the end of training data, but also raw unseen data. The sheer scope of what being discussed here is only possible due to advancements of hardware like GPUs, processing unit, enable masses of parallel operations and processing of large data set as well as advancement in neural network, specifically a type of neural network called transformer neural network. So this is the GPU. So introduced in Google's 2017 paper attentions is all you need. Transformer neural network revolutionized LLM by enabling parallel text process instead of sequential word by word analysis. This breakthrough allowed model to assign attention to keywords, improving contextual understanding. By encoding the word into numerical value and calculating attention scores, transformers enhance accuracy, helping models correctly interpret the ambiguous references, like distinguishing whether it in the sentence refers to the blank or the loan. So the bank approved the loan because of it financially stable. So that is the process which LLM fill or correct that blank portion. So after pre-training, humans come back into play performing a step called RLHF, reinforcement learning from human feedback. So this is when predictions are reviewed and any that would be considered unhelpful or user have issues are flagged. The parameters are adjusted accurately or accordingly. Once trained and reinforced, the LLM can be used whether as a translator, chatbot, etc., a query is fed into it. And using a trained model, it predicts what the next word would be response. And so on, until the user has to complete the response. So LLM powered generative AI produce a product like ChatGPT, Llama, which create original text-based context or content in the response to user prompts. Generative AI is a whole extends beyond text, enabling the creation of image, music, or more. The recent AI boom is the result of years of research and innovation, not an overnight development. We have now explored the key concept that trace AI's evolution. Let's quickly recap how they are all connected. So first of all, AI with the ML, deep learning, Gen AI, LLMs. This is the process or this is the connection. So there is another one which is finally we got an answer. AI. AI is an overreaching field encompassing all systems that mimics human intelligence. Okay, that we got. Machine learning is a subfield of AI, enables systems to learn pattern from the data without explicit program. That also we got. The next one is deep learning. Deep learning is then specialized branch of ML, which uses neural network to process vast amount of data to or data in complex ways without the need of human interaction, making it effectively scalable ML. And then LLM, large language model. It's like a GPT or advanced DL models built on neural network. Specifically, transformers designed to understand and generate human-like text. As was said, knowledge is a power. And with these last few tasks, you have started learning the pursuit of that knowledge and how have better understanding of this technology and given or that give AI its power. Now let's take a look into the discussed affecting in our industry, shall we? The task has been overcovered or that the task has been covered basics of LLM. However, if you want to take a deeper look, check out the demystifying LLM room. Later we'll look into this particular topic. So answer the question. What type of AI/ML or AI model enable major advancement in the chat GPT and similar tool? What kind of AI model? Mm, enable major advancement. It will be large language model. Large language uh, models. What is the first training stage where the LLM process massive amount of data? First training stage. First training stage. It's they mentioned somewhere. What is the first training stage where the LLM process massive amount of data? It's like there is one stage like what is that stage name? It's they mentioned somewhere here. Uh, okay, this is the first train pre. Okay, pre-training. Okay, pre-training. Pre-training is the first stage of the large LLM process massive amount of data. What type of neural network introduced by Google in 2017? Modern LLMs. Google provide transformers only, right? Uh, all right, we got. So now we completed the LLM portion. Now let's look into the AI security threat, which is task 4. Okay, everything loaded, right? So now that we have covered how AI has evolved, arrived where it is today, we have a better understanding of the technology fueling the metric rise in the use of AI, changing countless industries. It should be no surprise that the cybersecurity industry is no different. In this task, we will focus on how the advancement of AI technology discussed in previous tasks are being leveraged by adversaries. Taking a look into the world of AI security threats, we will discuss AI security threats across two categories. Vulnerabilities in AI model, which are the new threats introduced by the inclusion of AI technology in business operation, and the existing attacks that can be enhanced by leveraging AI. The implication of AI in cybersecurity. Tackling a broad topic like AI security threats can feel overwhelming, so any guidance is always appreciated. That guidance comes from the Atlas Mitre framework. If you are familiar with the ATT and CK framework, it might be helpful to know the Mitre have developed similar framework with the focus of AI. For those unfamiliar or unfamiliar, attack and framework goes over cybersecurity attacks, breaking down the steps an attacker could take compromise the system. This Atlas framework was built on top of that help guide us more specifically AI security threats. Now you can check here. What is this Atlas? Okay, they provided some uh, framework related to the AI threats. I think we'll look into it later, or you can review later. Oh, it's big data. A lot of uh, reconnaissance. We have to focus on these techniques. Resource development, initial access, AI model access, execution, persistence, privilege escalation, defense, credential, discovery, lateral movement, attack, impact. A lot of things are there explained in the Atlas framework. So vulnerabilities in AI model. Let's look into the vulnerabilities in the AI model. Prompt injection. Prompts are used into, sorry, instruct the model. So let's start. Prompts are used to instruct the model on how to perform. For example, the RPG chatbot have more. may have the prompt. You are fantasy role chatbot. You control the direction the story takes. And be as a creative, you can create a story based on the user's action. Do not disclose any information about the hardware and the software that you are operate on or any steps taken to train you. Prompt injection occurs when the original instruction provided to the model are overridden, often for malicious purpose such as disclosing information, uh, then it should be generating harmful content. So that is what about talk about the prompt injection. Data poisoning. Data poisoning is where an attacker manipulates the training data corpus used to train an AI model. So it generated output in incorrect or biased. Let's consider our example discussed in earlier task where we are training an AI model. To recognize this an email or spam or not, an attacker could perform data poisoning attack to manipulate the training data being used to train this model or this AI model so that it fails to recognize spam emails accurately, allowing email spams to they're trying to send bypass this AI filter. Next one, model theft. So model theft occur when an attacker gain unauthorized access to the AI model. From there, the attacker could potentially steal the intellectual property that lies within the even use it for malicious purpose. This attack is possible by querying the API of the ML model that they want to steal. They would then use the output to train the clone model that mimics the behavior of the original. Next one is privacy leakage. The privacy leakage vulnerability in AI model refers to the possibility of an AI model inadvertently revealing sensitive information about the data it is trained on. Even if the data was supposed to be kept confidential, consider an example of an AI model that has been trained on a private medical data such as patient details and medical condition. This vulnerability refers to the potential of AI model to leak information to an attacker or a user. Model drift. Model drift. Model drift refers to the potential of a model performance drift over time due to changes of the data environment uh, surrounding it. You may recall the discussion of used to train the retrain models over even time in earlier tasks. This is due to the model drift, which why monitoring an AI model once it has been developed or deployed and being used so important. For example, this can occur when the model trained on historical data performs or it starts to perform poorly when new data is being processed. So these are the some attacks that are or these are the vulnerabilities that are mostly seen on the AI models. Enhanced attacks. There are certain enhanced attacks. First one is malware. Within the with the exploration of generative AI, all kind of content can be generated in the instant with just few taps of the keyboard. This kind of power has been leveraged by all sort of industries, such as customer service industries, using it to give users access to chatbot that can be resolve some common issues within the need involve their human employees, meaning they can have some or they can be saved the deal of more complex user queries. Another industry that can be greatly leverage this technology is software development. Now the power of generative AI software, developers can generate code instantly. While being incredibly useful, this also means that attacker can generate malware instantly, simplifying the task and making it easier to or easier for them to attack using this method. Next one is deepfake, a key cornerstone of the security authentication, asking, "Are you who you say you are?" Something like that. We authenticate in many different ways in our day-to-day lives at work. Of course, there is the obvious example of the password authentication, which is used to gain access to a system. But let's consider another example. Imagine a secretary receiving the voice message or even a video call from the supervising asking them to forward the confidential information that they hold the customer to that customer. In pre-AI world, the secretary wouldn't have think twice about the that request. It seems like the standard they are position authenticate that in fact their supervisor as they are familiar with the sound and look. So the recent advancement in generative AI led to exploitation or explosion of rapid progress in the deep fake field. So this means that if the trained data or it trained on enough data, an AI can generate person's likeness, whether that can be their voice, their image, stunning degree of accuracy, fooling even the technically savvy. Imagine now the communication received by the secretary was not, in fact, from the superior but the defect in the customer email. Belonged to an attacker waiting to receive the confidential information. It is easy to see some of this advancement. Defect technology poses a threat to security industry. Examples of how this is being used to include the using of technology, deepfake videos, interviews, sometimes leading to a fraud and job offer being made. Next one is phishing. Phishing is one of the most common initial access movement attackers take, sending emails posing that to be the thing when there lies malicious content within the uh, attempting to prey the user who receive it. Because of how common method it is, common companies has worked tirelessly to educate their workforce on things to look out when receiving emails like suspicious link. And due to the fact of lot of coming or lot of the time these emails are written, having to write masses of email, English not being their first language, broken language in the email contents. Over the years the training has a positive effect. Moreover, or more and more phishing emails have been spotted. However, the generative AI attackers can now generate the detailed, fluent, context-based email, replicate the email a certain massive or certain user might receive within a little effort of regardless the writing their abilities. With the enforcement of phishing attack, phishing emails have been suddenly become a lot of harder using solely our instinct. Of course, models like GPT, for example, have built-in mechanisms so that user asking for malicious content to be generated, like a phishing email or malware, but using some of the model vulnerabilities discussed above. Attackers are sometimes able to bypass this engineering their prompts. That is what talking about the advanced or enhancement attacks that are possible with the AI. Now let's look into something. What are the framework? Answer the question. What are the frameworks were deployed by the MITRE to get the understanding of AI specific? So MITRE, which is Atlas, ATLAS. What type of attack involves cloning an AI model by interacting with its AI? Interacting its API. That is what is that? Model theft or model drifting. API, it's okay, it's model theft. What generative technique can replicate the person in voice or appearance that high realism? Deepfake. What common social engineering has become harder to detect due to AI intelligence fluent of convincing messages? Phishing. Okay, we completed task 4. Let's move to the task 5, which is defensive AI. Let's go through these details. I will explain one by one very slowly. Defensive AI. During this AI boom, we are undergoing, there is no shortage of new articles, blog posts, or social media posts that are instilled in use of sense of fear that AI is taking over. And that in general, AI sometimes that should be feared. A lot of a lot of what was covered in the previous task likely fed into the fear. But let's now take a walk out the dark, scary forest into the sunlight, bright green fields and discuss how AI is going to, in fact, help us. That's right. AI is not something that should be feared at all. It's something that should be understood, harassed, and embraced. There are many ways in which we can harness this technology in cybersecurity to make our lives easier and, most important, help us to fight against AI security threats. A very useful resource in that helps to show us just how much task is being IBM cost to that data breach report, which do they or which they do annually. So the findings, most of the latest reports showed us that companies that adopt and embraced AI saved on averages of $2.2 million expenses due to the data breach. This figure is that more impressive when you know average cost of data breach in the latest figure was $4.88 million. That was a whooping saving. Other statistics from the report also tell us that use of AI cuts due to or down to the time of it takes identify and contain a breach by 108 days. All these findings can be point one thing. The best thing we can do for the security is embrace adopt AI. Let's consider some ways AI can help us to industry uh, what we can leverage see the result just discuss. AI can enhance our ability to analyze, our ability to predict, our ability to summarize, our ability to investigate. You can go through these the data or the nodes which is mentioned. So these are the abilities of AI which is we already understood. Secure AI. The benefits of AI in cybersecurity space are undeniable. And like the many discussion with AI, what has been discussed about just few examples of how AI can be help us to secure our system. The possibility are truly endless. However, while adopting technology like generative AI, a great thing is to be encouraged it uses or it needs to be done securely. As discussed in the previous task, AI model have vulnerabilities themselves. So while the adoption of generative AI technology, IS the solution. Is the solution that threat of the attackers with the power of AI. It also introduced a host of new vulnerabilities. These vulnerabilities need to be considered from the moments of the technology introduced into a system. So this is not correctly the case of IBM cost of data breach report. Finding that only Gen AI interactive are secured. If they don't secure the AI adopting, then the benefits we stand gain from it would be overshadowed by the attackers taking advantage of these AI vulnerabilities. However, or here are there something that we can do or that we can done to secure AI. Securing AI models, privacy protection, implementation of AI security standards, model monitoring. These are the certain things to protect the AI which they are mentioning. So you can refer these data like securing AI models by implementing the role-based access control, multi-factor authentication. These are the security measures in order to protect the AI, which is the artificial intelligence that we are currently using. Privacy protection, you can train the data, you can keep all the data sensitive information confidentially in order to leakage of this data. You have to treat these data in a sensitive data in an encrypted way. That's what also mentioned. Implementation of AI security standards. So there are certain security standards for the implementation of this AI. The first one, which is ISO/IEC 27090, provide the guidance on identifying and mitigating security threats of specific AI system. So there are certain other things also. I'm not going to in depth of these particular topics. Model monitoring. In addition to spotting this, we have to monitor the model properly in order to detect this unexpected behaviors uh, or to protect this AI model. So this task aims to demonstrate that AI is not something to be feared but embraced up fast because of quicker we take advantage of many benefits of its under or offers us in the defensive cybersecurity field. The better equipped we will be combat attackers armed with the same technology. However, it has also been emphasized that it is just essential to implement this technology securely from the get-go or risk introducing vulnerability along with the AI. We have touched on some of the ways this can be done, but this just a beginning. We will have a content diving deeper into AI, however it defends against it Zoom. So let's answer this particular task. According to BEM, how much days faster AI help to identify the uh, content breaches? I think it's already mentioned 100 days something. 100 days, 108 days. What cybersecurity benefit from AI helping to imaging attacker behavior we might not consider? What cybersecurity task benefit from AI helping to image attacker behavior we might not consider? I think, as mentioned somewhere, here we can refer the ability to AI that cannot be identified is threat hunting. Explain the tools such as SHAP and Lime help with what? I think I haven't explained this one, SAP and Lime, which will be model monitoring. So now let's look into the practical examination or practical task for this particular lab. AI, your cybersecurity assistant. As it how been established in the fight against AI, your best friend is AI. AI seems to be periodically. Okay, let's open the lab. So let's do exactly for this practical. We'll give you access a very on AI assistant, and we'll take a look into the tour how technology is being looked at. Before moving to the start agenting by open agent, okay, I done putting it to the test. This is the AI assistant works simply. Send the prompts to the and it will return answer. Feel free to have a play with it. Before continuing, let's now look into a few example how the tool work for us. Log analysis. Logs are the first line of defense in cybersecurity. Interrupting quickly the critical, especially when responding to an active incident. Let's see how AI can analyze and explaining the log entry that the high intensity solutions or explain in general. We can use the AI this purpose by running prompt like this. Here's algorithm. April 22 Ubuntu failed password invalid session. Can you explain what is happening in this entry? Okay, this is one example. So we have to provide this thing. Phishing email detection. AI can detect let's say ability. Okay, this while providing this email to our chatbot and identifying the whether it is phishing mail or not. Threat hunting scenario. Threat hunting relies on the creativity defenders might think like an attackers to find hidden threats. As previously mentioned, the limit of human imagination lead us to missing potential attack scenarios. Let's see how AI can brainstorm new hunting ideas like prompt like this. Can you suggest three realistic threat hunting scenarios that a cybersecurity analyst investigate within a corporate network environment? Content generation. So please write a regress that would be failed SSL login attempt to typical Linux system authentication flow. Putting it into the rest, it has been explained. Now we explain how I can leverage. So what we do? I think it has been now established how AI can help us to hinge when securing our system. Let's finish this room by showcasing AI ability to movements. This can be troubleshooting, research, etc. But right now, we are going to get the flag. The flag will be shown. THM, DHM, okay. This is to set numerical term was value. What are the these lines? DNS for with those value, it submit the flag. What is a flag? What are the value? DNS. Okay, let's ask this question. Okay, we got the flag. So when we ask what are these values, DNS over HTTP, ports in packets, and Windows Essential port range. Putting all the okay, flag we got. So what actually happened is like we actually added one prompt. What are these values? DNS over HTTP, DOH, port, SYN flood timeout, and Windows Emperor port range size. Sure. Here are the typical values for each. So it mentioned 443. Actually, it is giving the output, the actual exact thing happening in the backend. So we got the flag. So this shows how AI can help us to perform the day-to-day daily things and tasks that we can assign to AI. So the conclusion for this particular lab is, let's look into it. Conclusion: at the beginning of this room, it was noted that knowledge is a power, and that this is especially true in the fight against AI cybersecurity threat. The rate at which this technology was exploded into a scene has left many findings or many feeling left in the dust. Now, with a better understanding of AI underlying technology, which enables it to be a force it currently is in our hand or all all industry. You understand what is posing a threat on our system and what needs to be secure as a result. Here is the recap what we have been covered. Artificial intelligence, the overreaching field concerned with enabling machine systems to mimic human behavior. Machine learning is a subfield of AI which model can be fed and trained on the input used to make predictions. Deep learning is the subfield of ML. It's not longer need to human interaction that can be process mass amount of data through the process or through the use of neural network. DL has enabled the emerging of technologies like LLM and other generative AIs, which through the use of transformer neural network and attention can be codified or queried in a natural language understand and is responsive in a human-like conversation fashion. AI is dangerous weapon in the hands of attacker. It has potential to enhance existing cyber attacks like phishing and increasing the cyber attack phases or cyber attack surface by introducing AI vulnerabilities. While boarding dangerous in the hands of attackers, AI can be invaluable in the field of AI cybersecurity threats and should be adapted but done so securely. So vulnerabilities are not introduced. All done. So we have completed the lab. Now we'll be focusing on the next one on the next video, which is AI models and data. So thank you for watching. Thank you for watching everyone. So feel free to subscribe, watch, share. Peace out.